Hello, my name is Kent Cartwright, CEO and founder of CyVectors here in Plano, Texas. Today I'm going to run through a few slides and a software demo and tell you a little bit about CyVectors sensors. So a little bit about me. I've been in the IT technology industry for decades, going back to the AT&T Lucent Technologies Bell Labs days. A lot of work with the government, including the Federal Aviation Agency, Homeland Security, and also some great work been done with the ransomware protection organizations I've worked for, software companies. Decades of fault performance and availability monitoring with some of the names you've heard of with Concord Communications, Mercury Interactive, Quest Software, CA Technologies, and a few others. An EC Council DoD certified ethical hacker. I've also been certified for the AI attacks by EC Council, taking some extra training and certification courses from them on that topic. I've received a certificate from the Institute of Cybersecurity Excellence for hacking OT networks, something I'm very interested in helping protect. And I am the sole software developer for the agentic AI sensors and vSOC solutions that I'm about to show you now. So I founded CyVectors in 2023, did the typical things you do with establishing the EIN number and the LLC and setting up the bank account. The company is pre-revenue. We've just completed the cycles of software development to give the complete sensor suite needed for the vectors we wanted to identify out of the gate. That includes about 15 production-ready sensors and one sensor that's in dev now for AI governance that will allow you to restrict agentic AI agents from going off the rails on what tools they use and what processes they use, and really increase the safety around that. So basically, CyVectors really took a leap forward in the last 18 months or so with the Onyx model that's been embedded in all of the sensors, which really put sort of a drop of AI in every sensor and really made them a lot smarter and faster. So we're really happy about that. Star of the show at CVX Expo 25 in Phoenix. That was a great event for us. And we are registered partners of SolarWinds and Splunk because we do want to provide this data to SIEM platforms globally, especially that have already been adopted by customers, so we can just plug into the security strategy and make it better. So the problem, and those who work in SIEM environments, security operations centers, the IT managers, you guys know that everything we've set up over the years is reactive by design. You're getting information, you're processing the information, you have thresholds, you have alerts, you have notifications, and then you have to go do something about it unless you have something automated, which can be very scary. So everything's reactive, and the logs are coming in, and the more logs you ingest, the slower the reactivity becomes. Blind spots across the attack surface area. We know that when we deploy things, sometimes we'll get a project that says, I'd like to set up exfiltration, I'd like to be aware of that, but then you realize, covering those servers, covering those network components, bringing the firewall in, adding all that log ingest, it really creates a project that can never be done. So the blind spots continue. And then some blind spots like business email compromise and things like that, we kind of wonder sometimes, what can we even do about it other than just hopefully train users and cross our fingers. And then cloud threat analysis, we're sending everything to the cloud. That's where the actual processing is done. Well, then you have to start thinking about what happens if I lose the cloud during an attack. How much delay is that cloud introducing to the actual analysis? And we would never ask you to get rid of that component, but it does introduce some things around risk that these sensors can really help with. And then, of course, alert fatigue. Alert fatigue is just a real thing. I've worked, in operations centers myself, and looked at those dashboards and looked at those alert consoles, and you just kind of try to find the red ones. It's just too much. And so correlation and ingest reduction and all these things, and simplifying the message into something that we can really use, is what the sensors really help address. And of course, the ingest costs, it's just become sort of a normalized pain now that just keeps going up. The bill keeps going up, and there's actually some things we can do about that. So with CyVectors and the sensors, you have distributed AI detection at the edge. We like to deploy what's called a sensor grid, where you would identify the most probable places where a threat or a breach currently exists, an assumed breach model. With these Onyx models down there at the edge, it's like having a security operations center engineer positioned at each one of your endpoints. These models are very smart. They've been heavily trained by CyVectors to do the jobs they do. And then, of course, full tier threat visibility. So you think about the attack chain where you have the endpoint email comes in, then you have the reverse shells going out, then you have the pivots going on, then you have the exfiltration. Sometimes it's tunnel DNS exfiltration, very hard to see. Then you have sometimes encryption that goes on with a ransomware attack or something along those lines where malicious file activity. So we need to put all of those vectors of vulnerability into full tier threat visibility and then integrate that into the SIEM platform. Otherwise, we're going to really be missing these attacks, especially now that AI is involved in performing the attacks. Things have got to be fast and they've got to be smart down there on the endpoints and at the edge. So, one thing we wanted to always do from the very beginning was make sure that the sensors report syslog, open telemetry, local log file, Windows event log. So anything you're using, anything you may have deployed that could receive this intelligent telemetry, there's an output for you. So it fits your existing stack, whether it's on-prem or in the cloud. The threat landscape, the fact of the matter is, especially here going forward, without AI as your ally in cybersecurity, you're likely to be impacted by that. If you're dragging your feet on really what's AI going to do for us here in the SOC, it's probably time to start moving forward. One of the fastest ways to start taking advantage of AI being your ally is to deploy these sensors where the AI is already inside of them. So it can take a very insignificant syslog receiver, and suddenly you have a 24/7 threat hunter on your hands. Correlation is always a problem. And you see the news with successful attacks. They always occurred at places where there's already, the top endpoint solutions deployed. And that gets back to our problems with blind spots and things like that. And with AI now conducting over 30% of the attacks that are successful and even multiple in parallel, the threat landscape has just become that much worse. So what's working for attackers and also correlates to what CyVectors has been building, human error by end user and the IT. Human error you see especially around email still. So we wanted to address all that and not only provide the SIEM platform with what's going on at the end user's endpoint, but also let the end user know what's going on so they can kind of join the fight. Malware, call home, command and control key loggers, those go from you out to the attacker over invisible connections. The firewall is not going to care about it because it's probably over port 443. And if they go blocking that, of course, nobody's web browsers are going to work anymore, which is why the attackers use them. So malware, call home, reverse shells, things like that, very hard to identify. Encrypted exfiltration, where basically your data is being stolen right through the network and outside over an encrypted connection, usually over trusted ports, and there it goes. The data goes right out. Data theft is very hard to identify, and about $500 billion a year is given credit to that problem just in the United States every year of data theft. So file exfiltration, encryption of file shares and cloud-based shares is a problem because they're hard to monitor. If you want to monitor shares, sometimes you have to attach something, this massive platform, into another massive disk, storage platform, just to get visibility into what's going on. So we wanted to identify solutions to that very quickly and get those out to you guys. CVEs, so these are your vulnerabilities. They happen, especially over time. And if you let things just sit, the CVEs will pop up. The bad guys will find them before you do. And now there's the thing they're going to leverage to get in. So we wanted to identify solutions for that, which you'll see here in a moment. We have a sensor that's going to stay on top of those CVEs for you. Service path degradation, denial of service attacks, things like that. As I showed you before, have many years of fault performance and availability monitoring. So this we have a sensor that vector scan that's going to check service paths for how they're performing. And then, of course, there's an Onyx model in there to let you know if subtle changes in network activity that are growing over time, especially, can be a great sign that something in the cybersecurity realm is going sideways. And so we've got a solution for that too. Wi-Fi, Bluetooth, man-in-the-middle attacks. It's one thing customers are doing now, and people we talk to, is they will use their existing Wi-Fi infrastructure to try to identify other Wi-Fi that shouldn't be there. That project never completes. And so what you basically end up with is a condition where someone could be in the parking lot using this, cigarette lighter type 12-volt adapter to run a access point with a laptop and call it, lobby guest. And so now everyone that's coming into your lobby at 8 o'clock in the morning sits down on the couch after they sign in, and all their stuff's going through a car out in the parking lot. So we wanted to definitely have a sensor around Wi-Fi and Bluetooth tracking devices and things like that. So we're going to look forward to showing you that. Now, OT environments where you have oil and gas or automotive manufacturing and all these millions and PLCs out there running, the gates to the dam that would flood the city below if someone were to attack it. These are environments where people don't like you to touch them. So we wanted to come up with an OT solution where security people in the OT environment could use this tool, this sensor, without touching any PLCs and still be able to tell what's going on, whether there's leakage to the internet, which PLCs are doing updates for their firmware, who's talking to who and why. And it makes it very easy to identify things that shouldn't be in the environment when you have a solution like the OT sensor that I'll be showing you. Our unique value, here's the list. I'm going to actually show you the software around that. We get asked about, what's our unique value, and people are kind of asking us how we compare to other organizations that provide endpoint solutions. But yeah, it's AI visibility on both sides of the attack, vendor specific sensors, specific sensors. So we want to cover business email compromise. We want to cover the reverse shells. We want to cover the exfiltration, not build something massive that we have to configure and try to bucket all that stuff in. And then, of course, the byproduct of all this that the CISOs and above love is the dramatic reduction in SIEM monitoring, ingest, and people, process, and technology to get the job done because it lowers costs. So the vSOC is a sensor data receiver that has been created by CyVectors. It's a great way to do a POC for the data. Some small, medium-sized businesses would say, I want to have this on my IT team's desktop. We're going to use this as our monitoring around these sensors. It can also forward data as syslog or alerts, but it's been down to the source code level designed to receive the sensor data and do some things with that you can do in any SIEM platform as well. So you can basically, especially if you have an AI SIEM platform, you can take the dashboard that we've created in the vSOC application and create a, say, Splunk query that would give you the same visibility in your platform as long as you have the sensors running. The sensors are compatible with literally everything because we use standard base output with around the syslog, RFCs, the open telemetry, the local log file monitoring, and the Windows event logs. So it just covers everything you can possibly think of. And no matter what you have in terms of this list, adding the sensors adds a level of intelligence that it doesn't have right now. And if you do have a platform that has AI already in it, it's going to really appreciate some of the Onyx output and be able to do root cause analysis much faster because of that. We also have API gateways ready to go for SolarWinds, SAS, Snowflake, SentinelOne, and Signos. The Signos application was used quite heavily by CyVectors during the threat hunt engagements with private investigators. Of course, SentinelOne's just massively adopted. And then our friends at SolarWinds, we always want to be in tune with them. So you can send the sensor data right up to your SolarWinds SaaS environment using an API key securely. And then the Snowflake, there's actually on YouTube, there's a video of how that works. And once you send the sensor data into Snowflake, it's really straightforward to create a CISO dashboard where all those stages of a cyber attack from email to exfiltration can be displayed in a dashboard where it's really a single source of truth, where a CISO or an IT director could really get a grip on what's the threat right now if there is one. So we get asked quite a bit, what's a sensor? We hear about agents all the time, and the quick sort of thought around that is an agent is sort of like, if you take an automobile example, an agent is sort of like the old fuel gauge, where you basically had this thing floating in the gas tank, and then the higher the gas was, the least resistance through the resistor. Now the electricity could go through a little more and push it over to the F on the fuel tank. These are all very analog and outdated approaches to things, and we see that quite a bit in cybersecurity as well. But we still see agents everywhere of where the fuel tank would be maybe the amount of CPU. The little thing, the agent is detecting that amount of CPU and pushing a gauge up to closer to 100% or 50%. And that did us really well for a lot of years, in monitoring and even in cybersecurity arenas. But what we need now is a sensor. And much like you would see in your automobile, the sensor is going to sense how much fuel is in the tank. There's multiple ways they can do that, but there is no mechanical thing going up and down to make the gauge go from E to F. It's a very delicate piece of sensing equipment that uses variations in electricity in an automobile anyway to know when something's happening. So if you have exhaust gas coming through here, the sensor will pick that up on its surface. Or if you have low tire pressure, it's picking that up on its surface. And so CyVectors created sensors that you place within vulnerable vectors, like you would see here on this automobile. It would be placed around the vulnerable pieces of your managed environment. And then, just like an automobile, when you detect problems fast, it keeps repairs cheaper. And in a business environment, it keeps revenue going. So inside of the sensors, we have this Onyx model, and it basically receives raw system data from all sorts of areas of the managed environment. And then the models have been trained on, when I receive these tensor inputs to the Onyx machine learning, what to make of that. And so basically that has been trained on thousands and thousands of rows of example data around what you might see. This is what you should think when you see that. This is what you should let the SIEM platform know. And there's really a lot of engineering that goes into training that model. And one example of an Onyx model they have out there is where you can take it, plug it into a pretty dumb camera, and then suddenly it can do face recognition. So that's kind of an easy way to think about these Onyx models, is you can take something like an agent, plug an Onyx model into it, and it becomes a sensor, or a camera, and it becomes facial detection and things like that. So it makes anything smarter as long as you can train it. And no external API calls at all for these Onyx machine learning models inside the sensors to work, which is really great if your environment loses internet and you're under attack and you need to be fast. Which, speaking of which, behavior analysis is in milliseconds. These Onyx models have a 50 millisecond inference. So when you go to ChatGPT and you type something in and hit enter, and you might get everything back in 30, 45 seconds, that process inside of these sensors takes 50,000th of a second. So it's very fast. And then it knows what to do with that data and then sends the related alert and information. So the lineup of sensors, sensor number one is the email vector analysis. We have one for Gmail and one for Microsoft Outlook and Outlook WebView. These are sensors for that first initial contact by an attacker of email. And not only is it letting the end user know with a red dot or a red banner in the corner, depending on which sensor you're using, it also lets the SIEM platform know that end user received that email, whether they opened it, where it came from, even geolocates it, and offers the end user ways to right click and report it and things like that. So the EVA for Outlook and Gmail, Gmail and the web browser, all covered as that initial attack point. LAN vector, the mighty LAN vector. So LAN vector looks at egress only traffic from any Windows endpoint or Linux. And it looks at the traffic in a way that firewalls don't, that your current endpoint monitoring doesn't look at it. It looks at it in a way where if a threat hunter goes out and looks at an endpoint and is looking for a reverse shell or a command and control or keylogger, the steps you have to go through to really find that using netstat and IP collection, and then geolocation, and then taking all that and associating it with a Windows process that's associated with an application, and is that connection there when the application's closed? What destinations are trusted? What destinations are threats? What destinations on my local network are trusted? The LAN vector sensor knows all that, and so it takes care of all those thoughts in near real time as your endpoint is communicating with the LAN and the WAN. All this is taken care of by the Onyx machine learning inside, and the notifications go out, as we've mentioned before, over syslog, OpenTelemetry, Windows event logs, and local log file as JSON format. It's all these sensors have been formatted to perfectly fit in with your current existing SIEM infrastructure or managed service provider. The OT sensor, you can run it on a laptop, or you can put it on a Raspberry Pi. You can just put it in the environment, and what it does is it passively watches the packets over a spam port, or it could just be over a hub or a subnet, and looks for all these things going on with Rockwell and Modbus networks. It never touches a PLC. It never pings a PLC. There's no network interaction with the sensor to the managed environment at all. And it comes with its own web page. So you can use this sensor on your laptop, go in, do a threat hunt, plug into a spam port, see all the activity going on with the OT environment, and create a report and turn that into the executives. The great thing about the OT sensor is you can leave it behind, and it will continuously report to either the vSOC platform from CyVectors or your SOC Team SIEM platform. CyVectors Sentry, this is where we cover the Wi-Fi and the Bluetooth visibility. It's also has the embedded Onyx AI for threat scoring. It knows when something's a tracker. It knows when how far away things are in terms of the device itself. So if you have an AirTag that you're looking for somewhere as part of a threat hunt, it will actually beep and let you know you're closing in on it as you walk around with your laptop. So CyVectors Sentry covers Wi-Fi, BLE, and has spatial reasoning, so you can actually see what's around you. Event Log Sentry, this is great for pivot points and really anything where you're managing the environment with Windows event logs and event log ID numbers. The Event Log Sentry installs with the event IDs we suggest that we need to be able to send for the Onyx model to really be smart, but you can add others to it as well. It currently already covers things like credential problems, SMB file share access, things like that the Onyx model needs to know if things are pivoting or if there's a security problem on an endpoint. DNS sensor was created because so much is going on with DNS and no one can get to the DNS server. It's one of those pieces of the environment nobody wants to touch. So now you can just put the DNS sensor on your endpoint and know what's going on with DNS activity from there, especially around things like exfiltration tunneling. Sometimes will be done through a DNS protocol. That's very hard to detect unless you have the DNS sensor. The exfiltration sensor is great to install with it. This is going to look for exfiltration of really any kind, and both sensors of the DNS and the exfiltration use a leaky bucket burst detection approach to find sustained exfiltration. It has some self-learning in it, and it has both of these have registry keys in there where you can actually bump up the thresholds manually if you want by factors. So great way to deploy these is to just deploy them, and then they will start sending you, once the buckets fill up, they'll start sending you anything they're detecting as exfiltration. It could be just little sporadic pieces of exfiltration. And then you can go into that registry key and bump the one up to a 2. Those sensors will become quiet, and then if there's ever exfiltration or DNS tunneling or DNS abuse of any kind, then those messages will start coming out to your SIEM platform. The file audit agent is a great solution when you want to monitor Windows file shares or Linux mount points shares. And what this sensor does is it creates, deletes, renames, file operation changes, all to the SIEM platform. And the Onyx model will detect bursts. So if you had 1,000 files in there and you went and deleted them all at the same time, the Onyx model is not going to like that. It's going to report to the SIEM there was a burst of deletes. It reports all the files that were touched, which user did it, timestamps, and everything. So you can really create some good strategies around this in terms of compliance. I have a CMMC environment for DoD contractor. I need to know that those files that are part of the contract are only being accessed by who should be touching those and when. You can drop this in and get that very quickly. Maybe I want to have a Windows file share monitored, send the event to the SIEM platform, and then have the SIEM platform disable that user's account. That's a great way to stop a ransomware attack, or really just anything that's malicious behavior. So great visibility there, integrates with the SIEM, and then from the SIEM SOAR, you can do all kind of automated reaction to what it's seeing. The log file sensor was the answer to, well, what if I have a log file that's just plain text and I want to look for a string match in that, and then have that go out to the SIEM platform as syslog. That's the log file sensor. In threat hunt environments, this gets used a lot for monitoring the log file for the antivirus. And then we can look for certain strings in there and have a syslog message sent. And that helps us correlate the endpoints, email, reverse shell, event log sentry data. Now we have a log file message from the antivirus. And then now the SIEM is really starting to put the pieces together. Node Beacon is host resource monitoring. This is your staple visibility that you get from your typical Windows agent, except it's got some add-ons here. So we've got the CPU, the memory, the disk, and the process. However, it does have an Onyx model in it. So now it's associating all that with not only which application is generating it, but also the network adapter. So the network adapter statistics for link connection and octets and speed, all these KPIs are now being brought into this Onyx model. And now Node Beacon has a view of your host really like you've never seen before. And this data that's being sent in terms of the network connectivity, part of it comes from the ARC cache of the endpoint it's installed on. So now you can have Node Beacon on multiple endpoints. The Node Beacon is reporting internally and externally what virtual connections the ARP cache has in it. And then suddenly you can start putting together pictures of which endpoints are all connecting to the same thing on the outside and which traffic is going. Then we have the pen test sensor. This is automated endpoint vulnerability scanner. It pretty much can be deployed maybe one per remote office, a couple per company. These pen test sensors can handle huge subnets looking for CVEs. And basically, it does parallel port scanning with high throughput. So it does this thing very quickly. It can find CVEs across subnets, endpoints, anything with an IP address gets checked out by this. And you basically just modify a CIDR subnet and it will expand or reduce its reach in what it scans. But it performs a deep scan across all these subnets that you tell it to. And it's always looking for those high vulnerability ports that we're looking for. But it also has a CVE database that gets updated every time it runs. So before it runs, it updates its database from the cloud. And if it can't update the database, it still runs. And it finds CVEs that not only are you not going to find with Nmap, but are just too much effort with things like Nessus. So, we do the Nessus scans, and then we have a meeting on Friday, and then there's this huge spreadsheet of things to do, and then we try to spend months closing those gaps, and then really nothing ever comes from it. But these sensors report to your SIEM platform what CVEs are out there, and it finds things that normal scans won't. So this could even be a replacement or a complement to Nessus scans in large environments, or a replacement for something expensive like Nessus in SMB environments. The T-route sensor, when we're troubleshooting subnets or we're troubleshooting network connections and things like that, one of the things that can tell you more about the problem than anything is a trace route. And we run a trace route from one endpoint out to the internet, for example, and it will tell you, the trace route command will tell you each hop along the way on the network, how much time it took, how much time it spent at each hop. Well, the T-route sensor takes that sort of technology and creates its own trace route connection from wherever it is out to whatever you tell it to. And then it takes all those readings from each hop into the Onyx model. And it can determine, it can precisely pinpoint where degradations in the network are occurring. And this can be a huge help in the cybersecurity realm, where you're wondering, is it my default gateway that's slowing things down? Is it once I reach the ISP, or is it the destination endpoint where denial of service or high CPU and memory consumption is causing congestion and things like that? So it's a great solution for maybe an end user environment out to a critical application, or maybe I just need to make sure this environment has a great connection to the internet. A common use for this is to just send it to 8.8.8.8, which of course is Google's DNS endpoint. So that's a great way to know how your internet connection is doing. But T-route sensor, every environment should have at least one going. Vector scan, we talked a little bit about before, but it's basically has a list of things to check. More high-speed parallel processing, and it's going to check latency per port, and then enclose all that into an Onyx inference, where it's going to give you per endpoint latency port numbers, encoded IP values, connection refusals, and it's all put into a global timestamp context. So it gives you immediate feel for how the different paths of your network are performing and whether there's any problems within that, in terms of latency, whether hosts are up and down, ports are open that shouldn't be, and things like that. Workload sensor came about during a time when I was at a trade show, actually, and a company was sitting next to me and said, "Hey, I wish you had a sensor that could determine the pressure that an endpoint is under as it's running an application. And then we can take that pressure load feeling and move processes around across multiple nodes to balance that pressure out, giving you, of course, balanced workload." So that was how the workload sensor was born. And now it does give you all of those KPIs around how a host is performing. But the Onyx model gives you one number called pressure, which is a 1 through 6 on the pressure that system is under, which processes are creating that pressure. And it also has an AI analysis in our vSOC for that, where it'll actually give you recommendations on which nodes to move in order to balance the workload. Syslog Junction was created just knowing this was coming, where someone in a managed environment needs to send syslog to one place and then have that forwarded to many places. So you may, for example, take the sensor data, send it to syslog junction, and have it forwarded on one hand over to the vSOC application from CyVectors, and then another copy of it is going out to maybe Splunk, and then another copy out to another syslog receiver. So it's a one-to-many syslog forwarding sensor. Sensor deployments are very simple. All sensors are wrapped in a setup factory installer where you basically just click next a few times if you're manually installing it. You can also deploy it with System Management Server, SolarWinds Patch Manager, Intune, all the things that are already deployed by customers for taking a Windows installation and pushing it out across multiple endpoints at the same time. So it's been built from the very beginnings to have things like answer files, or if you want to use Ansible, things like that. And then CyVectors can offer a threat hunt engagement where a certified ethical hacker shows up on site or sometimes over the internet to deploy the sensor strategically. That strategic deployment can be based on an OSINT investigation where your certified ethical hacker will look at the way an attacker would look at you and then determine on the edge there where to put the sensors, where a breach may be occurring right now. And then we like to talk to the client a little bit about, what systems seem to reboot on Fridays for no apparent reason, or what's that one system that has the high CPU and you can't really figure out, been trying to figure out for weeks, what's causing that, because when you go to Task Manager, nothing seems to be causing that high CPU. So those are great things to add into a threat hunt, and then we'll take it from there in terms of deploying the sensors for you. Then we take all the data that goes into our vSOC application from those sensors and create a threat hunt report. And then the goal would be to show the value in the threat hunt report and leave the sensors behind on subscription, so that you basically your SIEM platform, or if you're using the CyVectors vSOC, becomes a living 24/7 threat hunt. So we can know at this point in time, you're good to go because we've done the threat hunt, we've found anything that was there, and we're leaving the sensors behind so that you continue to have that visibility and coverage to know that things aren't going sideways after the threat hunt ends. So a little bit about the vSOC. It's basically down to source code level, created to receive the sensor data and then provide meaningful data in dashboards with zero configuration. Underneath the vSOC, it runs on top of a Llama, so you can load Llama 3, Mistral, other language models underneath it and have it do the analysis. We like the Llama 3. It seems to be the best at really just taking the sensor data and making sense of it. And also the vSOC has all the prompts already built for you inside the platform. So when you ask the language model a question, it pushes all the sensor knowledge into the question for you. So let's take a closer look at this. So the main page to the vSOC is the analyzer. Here's where you can chat with your sensor data, ask it, what are my top 3 concerns right now? Are there any reverse shells or things land vectors picking up, any CVEs, the pen testers? Let's talk about that with the AI. And this uses no internet. It's all local to you. And if the internet goes down during a cyber attack, you can still go to this box and ask it questions. This view is a log search plus the Wi-Fi Bluetooth spatial reasoning I mentioned earlier. So you can see in this cube here, it knows where things around you are in terms of Wi-Fi and Bluetooth. The yellow dots are the rotating MAC addresses. Those are probably tracking devices, air tags, and things like that. So this is a great place to see, is my sensor data reporting in, and how's my Wi-Fi looking around me? And are the rogue devices, people bringing their phones to work with the hotspot on? This will find this for you and even tell you how far away it is. You can walk right up to it. Landscape view will tell you CPU, memory, and disk by site, kind of a high-level view of that. To the right of that, you see things being reported by the file audit agent sensor, who's touching which files and what share, and whether they were creates, writes, deletes. And then you see a T-route path at the top there going from the source to the destination, and which hops were degraded according to the Onyx model. This is a view which is topography. So topology is what's connected to what. Topography is what's related to what. So this is a quick view of a site. The legs are the nodes on the site, and then the dots are the AI-generated alerts from the sensors. So you can quickly see which nodes are having problems on which sites. This is for the workload sensor. Works with that to show you, you see there under the reporting endpoints, this yellow number is the pressure number. So this node's under a lot of pressure, a 5.0, because the memory over here is at 82%. And so it takes all these KPIs and then gives you AI recommendations on which nodes you can migrate to balance the workload. The attack surface radar takes all the sensor data. You are in the center of the radar. So as dots move closer to you, that means the threat is getting closer to you. Many times you will see the greens out on the edges, the yellows in the middle, and the oranges and the reds closing in on the center. So it's a great way to see visually how's the surface area according to the sensors and what I should be really worrying about. On the left there is what AI is telling me, and then on the right in the text is the related syslog messages. This is the vector scan dashboard, so it's checking those network paths and reporting back where any delays are by port number, and threw in a little spark line there to give a little bit of history. And then on the right-hand side there, you see the vulnerabilities are being reported by the pen test sensor. So it's just a great place to see how are my network paths, are any vulnerabilities associated. This is the license proxy gateway. Basically, this comes in the vSOC. CyVectors provide you a license key. You drop the license key in, and then all of your sensors report to this. And then this gateway will check the cloud every 24 hours and make sure that the sensors are still licensed. And if they're not, anytime a sensor either fails or becomes unlicensed, which I got to admit, I haven't seen a sensor fail in a long time, but if it becomes unlicensed and can't start, it will just fail open, and out of the way. So any Windows service that's a sensor just gets out of the way if it can't license. So there's no degradation to the environment. But licensing is very easy with this, and it's perfect for managed service providers. This is the node beacon data where you have the CPU, memory, and disk coming from those hosts being aggregated into a dashboard. The Onyx model gives you the TS value here, which is threat score. So you can have KPI problems, but if it doesn't see a threat around that, this will be green. So here we have a memory problem on this node and a memory problem on this node, but our threat scores are green on both. Node beacon in action. This also comes from Node Beacon. These are the net vector paths sent from Node Beacon, and this is how you can get your SIEM to look at things, where on the left-hand side we have the internal nodes and the outside what they're connecting to on the internet. This is a great way to see if multiple PCs are connecting to an attacker's command and control and things like that, and this can also be alerted on. Everything's geolocated from LAN vector or the endpoints who have the EVA for Outlook or Gmail, the DNS sensor, the exfiltration sensor. If those sensors start going off, this map will show you the destinations for those connections. Here you see we have some on the West Coast. We have a DNS sensor going down there around Texas, and then a LAN vector connection over there. I believe that's somewhere around the Middle East, China. And then the APID is our latest dashboard. It takes all the sensor data in your environment and stitches together what it's seeing based on the time, the node, the sensor, and the vulnerability. So here you see we have the red flashing as a LAN vector. We have a reverse shell going out to the IP address that's in the black circle over port 443, but we also have associated DNS sensor that's connected to that LAN vector problem. This can go from business email compromise out to LAN vector, and then go out to event log sentry where they pivot, and then this map could take you into exfiltration and DNS and file activity from the firewall agent, and it stitches together the entire attack path. So it's a great way to kind of keep this up maybe in the security operations center, because it should be empty, and if anything shows up here, it also can be alerted on. Thank you, and next I'm going to show you a little bit of some live software. Here we have a typical Microsoft Outlook that you usually see in business environments, the O365 version. In Microsoft Outlook, we've installed a EVA for Outlook sensor on this node. What that basically means in Outlook is that it will show up as an add-in to Microsoft Outlook, kind of like you would see with CRM applications and things like that. But there you see CyVectors for Microsoft Outlook. It's an add-in. And then once the add-in's installed, what you want to do is install this on, my computer, everyone you work with in the office, people who are trusted partners, and it's the end of business email compromise, and I'll show you how. So basically, I'm gonna go over here to my email, and I'm going to send this Outlook an email, and I'm gonna call it, we'll have a subject of "send me that spreadsheet." Seems simple enough if it's coming from a coworker. It's completely disastrous if it's coming from an attacker. So I'm gonna go ahead and hit send on that. And then over here in our Outlook, we should see that email arrive in a moment. And there it is. And what you'll notice about this email is it has a green dot on it. CyVectors verified sender. That means this email came from someone else who has the Outlook add-in, EVA add-in installed. So it creates these circles of trust. So in the registry, there's a key that is a channel number, basically. Right now it's on channel 1. Everybody on channel 1 who emails me is going to have that green dot in both directions. Maybe I want to have the finance department on channel 5, the IT team on channel 3, or maybe the entire company's on channel 3. And this makes it where when someone says, send me that spreadsheet, and it comes from the CEO and it's got a green dot on it, odds are it's the CEO. So this really takes a big problem out of business email compromises, spear phishing, and things that are very direct in the work environment. Now I'm going to go into begin an attack sequence using email, which is, of course, is still the, unfortunately, most common way these things happen. And I'm going to fire up my Kali Linux here on a different screen. Now I'm going to pull this over here. All right, so I'm going to go in here and send an email from mail.com, which is one of those mail domains that's commonly hijacked for doing malicious emailing. And I'm basically just going to resend an email to the CyVectors support link or email address, which is also the email for that Outlook we were looking at. I'm basically just going to say resend this email so that it comes from mail.com and send this over to support. Now, this is not coming from my Outlook, is it? It's coming from mail.com in a web browser. So this is not coming from another Outlook add-in from CyVectors. This is coming from a known threat. And so basically, CyVectors has, says to use caution with this message, and we have this red dot on it now. So, you know, if we have someone who says, send me that spreadsheet, and it comes in green, and we have someone that says, send me that spreadsheet, and it comes in red, suddenly the end user is in front of the attack, something we never see. In fact, if I go ahead and click on this because I want to open that red dot, there's a pop-up box. Now, this pop-up box is a code, like a PIN code you can enter. I'll put in 1234 for this one. But this PIN code could be something that only that end user knows, or it could be something that only the IT knows. If you want to get very strict, you know, IT has to tell you what to type in here to open that red dot email. Or it could just be, here's another layer for the end user to go through to realize they're entering something here. So everybody knows it's 1234. They use it that way all the time. I have this email here where everything looks great. And it says to get your funding quote for, you know, we're glad to have you as a part of the business startup funding group. It's something this receiver's been wanting to see for a long time. Here's all your benefits. Click here to get started. Now, if I bring my, go ahead and let that open and you'll see, wow, welcome, Kent Cartwright. We're glad to have you in the business startup funding group. Well, if I bring my browser exploitation framework back over from my attack workstation, and we'll take a look at what's called BEEF, Browser Exploitation Framework. And I have that browser. So they clicked on the button or the link in the email message. That hooked their browser, and they're using Edge here. And basically what that means is that when that click happened, it injected JavaScript into the browser. This works for Chrome or Edge or any other browser. And so once the browser's hooked, we now have a connection into that node that even includes a network loopback where you could even pivot from here. Just a hooked browser. And, you know, it's very simple to do to get your browser hooked without even realizing it, just from an email or maybe some way they subtly got you to a website. Now, once this connection happens, this in JavaScript injection happens, we can do lots of things. So I have code running now inside that browser. So there is a thing called pretty theft. And if I go in here and click on the Windows one and I'll click execute, and now we'll drag this out of the way. You'll see over here on my open browser, excuse me, we have a pop-up. So basically, I'm going to type in here RDP user and then password. Now, this pop-up came from the browser being injected with code from the link that got opened in the email, and boy, it looks just like a Microsoft box, right? So the end users, what they'll think is, I must have opened something that it requires Microsoft permissions to read. And they get popped up, things pop up like this all the time at work, you know, and people just start entering their credentials, and IT is the worst about it because they get posed with this even more often than anyone else. So they're used to just throwing their credentials in to get somewhere. Anyway, what we want to do is we want to steal the credentials from this person, and I'll click sign in here. And now if I go back to my attack station, bring that over here. Our beef has received the click. So the person entered their login, their password. I double click this, and it turns out they entered RDP user password 123. So my ultimate goal of all this was to go after a an RDP server, and we'll just take a look at that. This is what started the attack. The attacker saw this RDP server on something called Shodan, and this is a tool used in open systems intelligence. And they said, here's the IP address. It looks like it's a CyVectors server. What I need to do is I need to send that email to their support, get those credentials, and I might be able to get into this RDP server. So we now have the credentials, and we're going to go ahead and get this situated here. All right, so now I'm going to use a command here in my attack station, and I'm going to put in the RDP user login, the password that we took from the box that popped up when the user sent it to us, the IP address that we got from Shodan, and I'm going to say ignore any certs. So basically, I'll go ahead and put those credentials in, and we'll see that now we're hitting the RDP server that we saw in Shodan, and it has let us in. So on this node, though, they had exfiltration sensor running, the DNS sensor is running, and land vector is running. Now I have a script that I have standing by here that will perform exfiltration using DNS tunneling and make a connection over to Vietnam and some other places where the exfiltration is going. So I'm gonna go ahead and kick that off now. The sensors are going to see that activity happening where now the traffic has picked up for DNS. It's going to see the encapsulation. It's going to see the exfiltration. And land vector is going to see that the connection went out to a known threat place. And then we're going to take a look at, over in the vSOC, what you can do in vSOC, but you can also do in your SIEM platform, even more importantly. So if I go to the API ID tab here, you can see that the vSOC application has stitched together the red land vector dot you see here, the exfiltration place that's going out here. This is the external node that land vector saw the connection going to, and then we have the event log sentry, which is seeing the event IDs for this attack occurring, and we have the exfiltration sensor and the DNS sensor all showing us that this attack is happening while the vSOC stitches it all together. But the important thing to know here is that in any SIEM platform, even something like SolarWinds SIEM, Security Event Manager, which is a very basic syslog receiver, you can now put these sensors in your environment in a sensor grid, send that data to any syslog receiver, whether it be something very basic or a logarithm that has AI built into it, and it's going to be able to piece these together in this way where you can see very quickly in a single message there is exfiltration, or in a single message there is business email compromise. Instead of trying to ingest all the logs that would typically go into that endpoint, its related switch, its router, the next switch, the firewall, and all the pieces that you'd have to do to piece together an attack like this. This was done with just a few sensors and a few lines of code right here in the vSOC. So this can all be simulated in your Splunk platforms, your logarithm platforms, QRadar, or if you want to have this on your desk, we would highly recommend that as well. Maybe you use Syslog Junction to send the data to both vSOC and the SIEM. So the vSOC platform is a great way to POC the data, get to know the syslog data, get to know what your SIEM is going to be receiving. Once your SIEM does begin receiving that, it's going to have the benefit of all the great syslog data, including the very intelligent Onyx scoring that your SIEM platform can use to make decisions without even having to read the rest of the syslog message. So thank you for watching this demo. If you have any questions, you can reach me, Kent Cartwright, on LinkedIn, or shoot an email to support@cyvectors.net. Thank you.